We are learning a little bit of multiple integrals. Multiple integrals include line integral, double integral, and triple integral. Line integral is concerned with the calculation of the perimeter. Double integral with the calculation of the area, and in turn, the triple integral in the calculation of the volume. So we'll see problems on line integrals. So here we have a problem. Evaluate integral of 3x minus 2y dx plus y plus 2z dy minus x square dz, where c is a curve given by x is equal to t, y is equal to 2t squared, z is equal to 3t cubed. So actually this is integral of f dot dr, where f is a vector and dr is another vector. So f dot dr, we apply the dot product formula, and what we get is the integrand of this line integral, which is 3x minus 2y into dx plus y plus 2z dy minus x squared dz. Now, since the integral contains all three variables at the same time, it is complicated to integrate this. So we need to reduce all the three variables into a parameter t using the curve relation given here. So we have x is equal to t. In turn, we'll find dx. Y is equal to 2t square will give us dy, and z is equal to 3t cube will give us dz. So find all these six values like x, y, z, dx, dy, dz, and then put it in the integrand. So then we will integrate. So when we simplify f dot dr, we get 3t minus 4t square plus 8t cube term plus 15t raised to 4. So we get a big term. We will put it inside the integral between 0 to 1. Those are the limits of t. So all our variables are reduced to the parameter t along with the dt. And now it has become the normal integration. So we'll integrate using integral x raised to n dx formula between the limit 0 to 1. We'll put the values and then put the upper limit, lower limit, and we'll get the answer 31/6. So this is how we do the line integral part. Now coming to the double integral, we have a sum here in double integral over r xy into x plus y dx dy over the domain D, which is a parabola, x square is equal to y, and the line x is equal to y. So we have to integrate the question in the enclosed region between the parabola and the straight line. So we have to find, to get the limits, we will have to find the point of intersection of y is equal to x and y is equal to x square. So we know that the point of intersection is 0, 0 and 1, 1. So we take those 2 points as 0 and a, and then we come back to the integrand. The integrand will simplify, like we'll make it x square y plus xy square, and then go ahead with the integration. So we know as soon as we get the region of integration, we can find the limits. So since y is the outer limit, y should have number limits. So y ranges from 0 to 1. And x ranges from x in the region, in the enclosed region between the curve and the parabola. The x value starts from 0, but then we should not include all the region. We need only the enclosed region. So the lower limit of the inner integral x will be x is equal to y, which is a straight line. Okay, and then we integrate over the region, and we have to stop the integration when we touch the curve. The curve equation is x square is equal to y. So there the x value is root y. So the limits of the inner variable will be y to root y. So we'll integrate it by taking y as outer limit, x as an inner limit. Now, if we interchange it to x becoming the outer limit and y becoming the inner limit, we can do it as x limit is from 0 to 1 and y limit. Y means a height. So y limit will be from the curve. So y is equal to x square for the curve. And then we integrate along the region, and then we stop when we reach y is equal to x. So if we are taking y as an inner variable, then the limits of y will be from the curve where y is equal to x square to the straight line where y is equal to x. So in this example, they have taken y as an inner limit and x as an outer limit, and we go ahead with the calculation. We get 3/56. Now we'll have a look at the triple integral. Triple integral, as I told you, is concerned with the volume. So here we have the volume of a tetrahedron formed by the planes x0, y0, z0, and 6x plus 4y plus 3z is equal to 12. So volume is always, the volume is given by triple integral over v dx dy dz. So it represents the length, breadth, and height of the system. So now to check the limit of z, which is a innermost integral, we'll take z as innermost integral, y as a middle one, and x as a outermost integral. So we attach number limits to x, variable limits to y, and variable limit to z. So going back to the plane to search the limit for z, we can see that 6x plus 4y plus 3z is 12. So that will give us z value as 12 minus 6y minus 4y divided by 3. So the limit of z is from 0 to 1/3 of 12 minus 6x minus 4y. Now, as soon as we integrate z is lost. That variable is gone. Then it came to two-dimensional geometry. So hereafter, we have to take z value 0 and then take the limits of y. So in the plane equation, when you put z as 0, the equation becomes 6x plus 4y is 12. So there, the y value will be 12 minus 6x by 4. So the limit of y, the middle variable, y limit is from 0 to y limit is from 0 to 12 minus 6x by 4, which can be simplified to 3 into 1 minus x by 2. Okay. Now, z integration is over, y integration is over. Now we are left only with the x limit. So in the plane equation, when you z is 0 and when you put y is equal to 0, we are left only with the x variable. So that makes us 6x is equal to 12. So that will give us x value as 12/6. So the limit of x in turn becomes x is equal to 0 to x is equal to 2. Now we put all these limits in order and then continue our process of integration. So z is an inner variable, y is a middle variable, x is a outer variable. We go ahead with the integration and then we get the answer. Okay, thank you.